two pieces of equipment. One built in the 80s, one built in the 90s and built for the future. Other than the fact that one looks a little newer, they don't seem much different. But they are very different. The newer one answers an off-road industry demand to give us a piece of iron that does more work in less time. The new equipment does that very well. But to achieve that new level of performance, manufacturers had to rethink the Powershift transmission. They had to increase power densities beyond limits possible using engine oil as a transmission fluid. That meant developing a new kind of fluid more highly efficient at transferring power into work. It also meant re-engineering the Powershift transmission around the capabilities of this new fluid. The result is a new generation of off-road and farm equipment that delivers exceptional productivity, but only when using a dedicated transmission drivetrain oil. In this video, we'll look at the technology of the Powershift transmission, see how it works, and see why today's newer transmissions need a dedicated fluid to work the way they were designed to work. The goal is not to sell fluid, but to prevent field problems that can arise from the use of engine oil in transmissions designed for a dedicated Powershift transmission fluid. The Powershift transmission was designed for productivity. Many off-road applications require considerable gear shifting and changes in speed. Activities such as dozing, ripping, prying out stumps and rocks, side cutting, pulling implements, skidding logs, and finish grading. A Powershift transmission allows rapid and frequent shifting without loss of power. It also reduces operator fatigue. Both these effects increase productivity. But to achieve them, a Powershift transmission must do one thing exceptionally well: allow friction materials to engage instantly and hold without slipping. If it can't do that, all kinds of problems result. Clutch plates in both the transmission and wet brakes wear out prematurely. Pumps wear out prematurely. Shift response is reduced. Brakes slip. Less work is done, and maintenance is increased. Unfortunately, in today's equipment, engine oil is less effective at keeping friction materials from slipping. There's a basic design reason for this. To prevent slippage, a transmission fluid must preserve friction, but an engine oil is engineered to eliminate friction. In the past, this was not a significant problem. Engine oil has a certain holding capacity, just as transmission fluid has excellent lubrication characteristics. But the increased horsepower of today's engines has pushed power densities beyond the holding capacity of engine oil. In short, engine oil in a transmission is operating outside its engineering limit, and slippage is becoming a big problem. Let's take a look at how slippage affects different components of the transmission, wet brakes, and final drive. There are two types of Powershift transmissions: planetary and countershaft. The planetary gear set derived its name from our solar system. Picture our own sun with the planets revolving around it. In a planetary gear set, a sun gear, which is its actual name, engages planetary gears which revolve around it. These gears are held in place by a planet carrier. They in turn engage and move a ring gear. Planetary transmissions include an arrangement of gear sets which are engaged and disengaged by hydraulic clutches in different combinations to deliver a wide variety of speed and torque. In another kind of Powershift transmission, called a countershaft transmission, the hydraulic clutches transfer power by engaging and disengaging a series of counter-rotating shafts. But in both cases, hydraulic clutch operation is basically the same. Pressurized oil pushes a piston against the clutch disc and plate, clamping them together. The discs are splined to the drum, while the plates are splined to the hub. This sends power through the drum and on through the hub to the output. When the oil pressure is released, the piston retracts, the discs and plates separate, and power flow is stopped. Dedicated Powershift transmission fluids are designed to allow clutch plates to engage without slipping, efficiently transfer power, then disengage quickly. The net result is improved shift time. Shorter shifts improve equipment productivity, increase transmission durability, and reduce operator fatigue. Fast shift response between forward and reverse is equally important, since some off-road equipment operates in forward and reverse equal amounts of time. A dedicated fluid's friction properties provide effective shifting in both forward and reverse to improve equipment productivity. An additional benefit of shorter shifts is reduced lockup time for friction materials. Shorter lockup times mean less heat is generated and less friction material is degraded. This further contributes to clutch durability and transmission life. This is not the case with engine oils. Since engine oils were never designed with a holding capacity to match today's power densities, clutch plates tend to slip when they engage. Since the frictional materials are slipping, more pressure has to be applied to transfer power, while keeping the friction materials in contact longer. Excessive heat is generated. This results in unacceptable thermal degradation of the friction material. Thermal degradation can also lengthen shift response. This makes it harder on the operator. You can push the shift lever as hard as you want, but you won't get better response when a fluid is operating outside its engineering limit. Higher power densities have already increased operating temperatures inside the transmission. Slippage generates more heat. Engine oils don't have the oxidative stability to withstand these new levels of thermal stress. A problem called glazing can result. Friction materials are porous. As they're squeezed during engagement, oil oozes through the material to the surface, where it dissipates heat and prevents wear. Through a process not yet completely understood, oxidative byproducts from the oil can form a glaze on the friction material. This reduces the material's porosity and restricts the flow of oil. With less oil flow, there's more heat, more oxidation, more glazing. The problem quickly compounds itself until the clutch fails. All of these thermal degradation factors combine to reduce clutch life. Here's a clutch from a transmission using engine oil. This wear is after 7,695 hours. Here's a clutch removed from a transmission using a dedicated fluid after 7,932 hours. Notice the difference. Heat and wear from slippage affect other systems as well. Slippage increases friction and heat. Heat causes the plates to warp so that they wear unevenly. They contact each other only at high points and wear away friction material. Bits of this friction material move through the system like little cutting tools. Damage can be significant, as you can see in these prematurely worn parts. Another danger from clutch debris is the plugging of minute orifices in solenoid-controlled transmissions. Fluid flow can be severely restricted, and catastrophic failures can result. Since a slipping clutch requires more pressure to transfer power, lockup pressures are greater. This accelerates pump wear. It also reduces the efficiency of the equipment. The oil that actuates the hydraulic clutches flows through the control oil route. Oil also flows through another system called the lubricating oil route. This oil cools and lubricates the transmission, clutches, and brakes. Wet brakes operate with clutches just like the transmission. And just like the transmission, slippage occurs when using engine oils rather than a dedicated fluid. This is not a safety issue in equipment such as bulldozers, since brakes are used for steering. But slippage makes control more difficult, and that adds to operator fatigue. The excessive heat that results accelerates wear, and inefficient brake operation steals power that could be used to do more work. In off-highway trucks, brake slippage is a safety issue. Inefficient brake operation increases stopping distances and can be a significant factor in keeping a vehicle stopped while parked. Correct friction performance is necessary for safe brake operation. In vehicles such as rubber tire loaders, wet brakes and final drives have the same sump. Powershift transmission fluids of the proper viscosity are designed to work in this type of system. In fact, some manufacturers use a dedicated fluid as the reference fluid for the entire driveline. Another problem with the use of engine oils today is compatibility with friction materials and elastomers. Today's transmissions and final drives are a complex composite of many different friction and seal materials. Powershift transmission fluids were designed with these materials in mind. When not used, Incompatibility problems, such as seal swelling and embrittlement, can result. This leads to seal leakage and premature transmission failure. Today's transmissions were designed around the use of a dedicated fluid. It's an engineered component just like clutches or gears. It has the holding capacity to match the power densities in today's equipment. It has superior oxidative stability to prevent high-temperature deposits. It is compatible with the wide range of frictional materials found in today's transmissions. It provides instant shift response in both forward and reverse. It reduces wear in pumps, brakes, and transmissions. And it eliminates the many field problems you can experience by using engine oil in today's advanced transmissions. The effect on your maintenance cycles can be dramatic. In fact, by using a dedicated transmission fluid, it is not uncommon for transmission maintenance cycles to double, matching engine maintenance cycles. That means less than half the maintenance, more than twice the time on the job. Which means each piece of equipment will do more work over its lifetime for a lot less money. And that's what Powershift transmission fluids are all about.